Hi everyone, today we're going to study factoring. Specifically, this is factor the greatest common factor, GCF, from a polynomial. First, let us define greatest common factor. The greatest common factor, or GCF, of two or more expressions is the largest expression that is a factor of all the expressions. How to find the greatest common factor? We're going to follow some steps. Step 1. Factor each coefficient into primes. Write all variables with exponents in expanded form. Step 2. List all factors matching common factors in a column. In each column, encircle the common factors. Step 3. Bring down the common factors that all expressions share. Step 4. Multiply the factors. Let's have an example. Find the GCF, or greatest common factor, of the three terms. 21x cubed, the second is 9x squared, the third term is 15x. In step 1, let us factor each coefficient into primes. We write all variables with exponents in expanded form. So the 21x cubed is now factored out into 3 times 7. That is the prime factors of 21. And for the x cubed, we are going to write the x here 3 times. For the 9x squared, this is equal to 3 times 3 times x times x. For the 15x, this is equal to 3 times 5 times x. Step 2. List all factors matching common factors in a column. So the factors are now written like this. For the common factor 3, it is written in one column. There is also another common factor of x written in another column. It says in each column, encircle the common factors. So we encircle the 3, the common factor 3, and also the common factor x. Step 3. Bring down the common factors that all expressions share. So the 3 is brought down here, also the x. And then the step 4, we will multiply the factors. So the greatest common factor equals 3x. Let us go to factoring. What is factoring, by the way? Splitting a product into factors is called factoring. Example, find the factors of 6. It is showing here that the factors of 6 are 2 and 3. We know that there are other factors like 6 times 1 for this number 6. However, for this topic of factoring, we will only consider prime factors. Let us note that prime numbers are integers greater than 1 whose only factors are 1 and itself. Examples are 2, 3, 5, 7, 11, 13, and so on. Let us discuss now factoring the greatest common factor from a polynomial. We're going to follow some steps. The step 1 says, find the GCF, or the greatest common factor, of all the terms of the polynomial. Step 2, rewrite each term as a product using the GCF. Step 3, use the reverse distributive property to factor the expression. Step 4, check by multiplying the factors. Let's have example 1. Factor the trinomial 6x cubed minus 9x squared plus 12x. Our step 1 says, find the GCF of all the terms of the polynomial. In here, the GCF is 3x. Looking at the numbers 6, 9, and 12, the greatest common factor of these three numbers is 3. For the variables x cubed, x squared, and the x, the greatest common factor is x. So the GCF of this trinomial is 3x. Step 2, let us rewrite each term as a product using the GCF. It means we're going to split each term. Look at the first term. The 6x cubed is split into two factors in such a way that one factor should be the GCF. So the 6x cubed is now factored out into 3x and 2x squared. The second term, negative 9x squared, is now factored out into negative 3x, the GCF, times the 3x. For the 12x, the factors are the GCF 3x and the number 4. For step 3, use the reverse distributive property to factor the expression. It means to say we're going to remove first the GCF from the three terms. So see, the GCF is now outside, and then on the second factor, we're going to collect all terms that will remain for each term here after removing the GCF. Look at the first term here. After removing the GCF, the 2x squared remains, so it is written here 2x squared. For the second term, after removing the GCF, only the 3x is coming, so this is minus 3x. And then plus, for the third term, after removing the GCF, only the number 4 remains, so we will copy here 4. Step 4, let us check our answer by multiplying the factors. We should go back to the original problem after the multiplication. So the 3x multiplied by the 2x squared, I will get that 6x cubed. And then the 3x multiplied to negative 3x, the answer is negative 9x squared. And then 3x times 4 is positive 12x. So we are sure that this is correct, and this is our final answer. Let's have the second example. In here, there are two big groups. It is a difference of binomial. Look at this first group here. It is a product of 3y times the quantity y plus 7, and then minus. The second group is 4 times the quantity y plus 7. Let us go to our step 1. Find the GCF of all the terms of the polynomial. So our GCF is this y plus 7. That is the common in the first group and in the second group. So I wrote here the GCF, that same y plus 7. Step 2. Rewrite each term as a product using the GCF. In this problem, it is already in the form of a product in such a way that one of the factor is the GCF. So we just copy that same problem. In step 3, use the reverse distributive property to factor the expression. So we're going to remove first the GCF. So removing the GCF here, we expect two terms in the second factor. In the first blank here, I'm going to write the remaining term after removing the GCF. So looking at this first group, I can see here that 3y will remain after I remove the GCF. So I will write the 3y. And then plus. For the second blank, I'm going to write here the remaining term after removing the GCF. So that is the negative 4. So negative 4 will come down here. So this is plus and minus. I will simplify this into negative 4. And step 4, let us check by multiplying the factors. So we want to multiply these factors and hoping that we will get back the original problem. So the first group is this 3y times the GCF. So this is our 3y. If I multiply by the first group or the GCF, I will get the first group here. And then this negative 4 multiplied by the GCF here, I will get the second group, the negative 4 times the quantity y plus 7. So now I am sure that this answer or these factors are correct, and this is our final answer. Today we're going to do factoring, and we will factor difference of two squares, and this is the form x squared minus y squared. Let us make a review for special product. When we multiply x plus y times x minus y, the answer is a binomial x squared minus y squared. The factors are called conjugates. It means the conjugate of x plus y is the x minus y, and vice versa. While the product, we call this difference of two squares. For today's lesson, we are going to do the reverse process. The problem will come to you as this product, and then you are required to give the factors of this form. How to factor difference of two squares? In step 1, rewrite the two terms as squares of some terms. Step 2, write the factors following the pattern. The x squared minus y squared equals the binomial x plus y times x minus y. Let us have example 1. factor the binomial x squared minus 9. For step 1, we will rewrite the two terms as squares of some terms. So the x squared is now written as the square of x, and then minus the 9 is now 3 squared. For step 2, we're going to follow this pattern. It means we expect two binomials in our answer. But take note that the signs must be different. One is positive, the other is negative. We're going to put x on the first blank of the binomials. And then the 3 will be the second term of each of the binomial. So we see here we have the x plus 3 times the x minus 3. So this is our answer. Let us have example 2. Factor 64y squared minus 1. Again, we're going to rewrite these two terms into squares of some terms. The 64y squared can be written as the square of 8y, and then minus the 1, we can write it also as the square of 1. And then for our answer, there will be two binomials. In the first term, it will be 8y. Also 8y in the first term of the second binomial. And for the signs, it must be opposite. One is minus, the other is plus. In our answer here, the negative comes first, followed by positive. And it doesn't matter as long as the signs are different. Now for the second term, we copy that 1. So it's now placed here and also in here. So our answer is the binomial 8y minus 1 times 8y plus 1. This is our final answer. Let us consider example 3. Factor the binomial 48x raised to 4 y squared minus 75 y squared. The terms are not perfect squares. We can see here that the variables are perfect squares. However, the coefficients are not. Therefore, these two terms are not perfect squares. But remember, we can check for greatest common factor of each term. I found out that the GCF is 3y squared. So if I pull out that greatest common factor, this first term here will become 16x raised to 4, while the 75y squared will be 25. Of course, the negative sign we will just copy here. So for our problem here now, we have monomial times binomial. And then we will check if this binomial here have terms which are perfect squares. The 16x raised to 4, we can write this as the square of 4x squared, and then minus. We know that 25 is a perfect square number, so that is 5 squared. And then we will just copy that 3y squared down here. And then we will have the step 2. For step 2, we are now expecting two binomials here. the first term will be the 4x squared. It's now here and also here. And then for the signs, we will have the plus and minus. And for the second term of the binomials respectively, it will be this number 5. It's now here and also here. So our final answer is this 3y squared times the binomial 4x squared plus 5 times the binomial 4x squared minus 5. And this is our final answer. Hi everyone. Today we're going to study factoring, and we are going to factor perfect square trinomials of this form: x squared plus or minus 2xy plus y squared. First, let us review our special product, the square of the binomial x plus y. And the answer is a trinomial x squared plus 2xy plus y squared. Also, if we have the square of x minus y, the answer is a trinomial x squared minus 2xy plus y squared. This trinomial and this trinomial are called perfect square trinomials because both of them comes from the square of binomials. For today's lesson, we are going to have the reverse process. The problem will come to you as this product, and you will be required to provide factors, which is the square of binomial, either of this form or this form. How to factor perfect square trinomials? We are going to follow these 3 steps. Step 1, check if the trinomial fit the pattern of the perfect square trinomials, either this form x squared plus 2xy plus y squared, or this form x squared minus 2xy plus y squared. In step 2, write the square of the binomial. And step 3, check by multiplying the factors. Let us have example 1. Factor the trinomial 25x squared plus 20x plus 4. Let us check if this trinomial is a perfect square trinomial. First, our 25x squared and the number 4, we can rewrite it as the square of some terms. So the 25x squared is now the square of 5x, and the number 4 is 2 squared. For the middle term 20x, what we will do, first, let us write the 5x in here and the number 2, and these are the bases of the first and the third terms respectively. And then we will multiply by 2. And this number 2 is always constant. When we multiply these 3 factors here, we are hoping that the answer will be the middle term. So 2 times 5x times 2 will give us that positive 20x. So it means to say this given trinomial is a perfect square trinomial. We can now proceed to our step 2, write the square of the binomial, and that will be our answer. So to write our answer, we're going to put 5x as the first term here, and that 5x is the base of the first term, and then plus this positive sign comes from the sign of the middle term, and the number 2, and this number 2 is the base of the third term. And then we will not forget the square outside. So this is our answer, the square of 5x plus 2. Now for the step 3, we're going to check our answer if it is correct. We're going to expand and hope that we will get back our original problem up here. So when we expand a binomial, it will follow this pattern here. So the 5x square, it will give me the 25x square, and that is the first term of the trinomial. If I square 2, that is equal to 4, and that is the third term of the trinomial. Now I will multiply 5x times 2 and times 2, and that is equal to 20x. So the square of 5x plus 2 is our final answer. Let us go to example 2. Factor the trinomial 16x squared minus 8xy plus y squared. I wrote my steps here. So first, I'm going to rewrite the 16x squared into the square of 4x and the y squared to be the square of y. For the middle term, first I will write the minus sign, and then the 4x and the y are written in the middle, and then times 2, and that is a constant. And I will hope that if I multiply 2 by 4x and by y, it will give me that 8xy. And it is. So it means to say this trinomial is a perfect square trinomial. So the pattern is satisfied. I can now go to step 2. I will now write my answer. And my answer, or my factors, is the square of the binomial. So I will collect the 4x. I will put it here as the first term of the binomial, and then minus. The sign comes from the sign of the middle term, and the second term here is the y, which is the base of the third term. Of course, I will not forget the square outside. So this is my answer, the square of 4x minus y. Going to step 3, I will check my answer if it is correct by multiplying the factors. Or I can say that I will expand my binomial. If I do that, it will come to this pattern. So if I square 4x, it will give me 16x squared, and that will be the first term of the trinomial up here. If I square negative y, it is equal to y squared positive, and that is the third term of the trinomial. Now, I will multiply 4x by negative y and times 2. That is equal to negative 8xy. So, my answer square of 4x minus y is correct, and that is my final answer. Let's have example 3. Factor the trinomial 100x squared y minus 80xy plus 16y. I can see here that the first term and the last term are not perfect squares. So I can say that this is not a perfect square trinomial. However, I can see that there is a greatest common factor among the three terms, and that GCF is 4y. So I will factor out the GCF, and for the first term, when I remove the GCF, what remains is the 25x squared. For the second term, what remains is the negative 20x. For the third term, what remains is 4. So it means to say, I have now a new problem here. 4y times a trinomial 25x squared minus 20x plus 4. Now I will check if this new trinomial is a perfect square trinomial. I will rewrite 25x squared into the square of 5x and that 4 to be the 2 squared. In the middle term, first I will copy the sign, the negative. Then I will take this 5x right here. I will take this 2, put it here, and then times 2. If I multiply the 2 times 5x times 2, this will be equal to the negative 20x. So it means to say, this is a perfect square trinomial. Of course, I will not forget my 4y to be copied down here. So I will now go to step 2 to write my answer, to write the square of the binomial. First, I will copy the 4y, and then for the binomial, it will be the 5x as the first term, then minus, the sign comes from the sign of the middle term, and then the second term is the number 2, which is the base of the third term. Again, I will not forget the power 2. So this is my answer. 4y times the binomial, or the square of the binomial, 5x minus 2. Now, for step 3, I will check if my answer is correct. First, I'm going to expand the 5x minus 2 all squared. So the 5x squared is equal to the 25x squared. It is written here. If I square negative 2, it will be positive 4. I'm going to multiply 5x times negative 2 times 2. It will give me the negative 20x. And the 4y here, I can write it there and then start to multiply the 4y to each term of the trinomial. And it will give me this original trinomial 100x squared y minus 80xy plus 16y. So I was able to confirm that my answer here is correct. And this is my final answer. Hi everyone. Today we're going to factor trinomial of this form, x squared plus bx plus c. First, let us review multiplying two binomials. in here I have x plus m times x plus n. So we know how to multiply this. I'm going to get the x from the first group and multiply to all the terms of the other binomial. So x times x is x squared. X times n is positive nx. The next is the m to be multiplied to the other members of the other group. So m times x is mx, m times n is mn. And then I can see that the two terms in the middle has a common factor of x. So I put the common factor x outside, so the other factor will be n plus m. Or since our last term here is mn, I want to interchange the n and the m, and there will be no issue on that. So here it is now m plus n multiplied by the quantity x. So when we multiply this x plus m and the x plus n, this is our answer. So for today's topic, that we're going to factor trinomial in the form x squared plus bx plus c, and to compare with our review multiplication on top, I can say that the b here is equal to that m plus n, and the c, or the constant, is equal to that product m times n. And then later, what we want to get are factors of this form, x plus m times x plus n. Now, we will learn how to factor a trinomial of the form x squared plus bx plus c. We are going to follow some steps. Step 1. Write the factors as two binomials with first terms x, just like this. Step 2. We are going to find two numbers m and n. And this m and n will be those terms that we're going to write on the blanks in the step 1. But there are two conditions for this m and n. This is the first condition. If we multiply the m and the n, it should be equal to the c. And this c is the constant of our trinomial. The next condition is, if we add the m and n, so that is m plus n, it must be equal to b. And this b here is the coefficient of the x in the middle term of the trinomial. So once we comply the step 2, we will go now to step 3. We will use m and n as the last terms of the factors. So it will be like this now, x plus m multiplied by x plus n. And step 4, we are going to check our answers. We will check by multiplying the factors, and it must come back to its original problem or the original trinomial. Let us have some examples. Example 1. Factor the trinomial x squared plus 13x plus 30. Step 1 says, let us write the factors as two binomials with first terms x. So I wrote like this, the x plus blank and then x plus blank. In step 2, let us find two numbers m and n such that the product of these two numbers is equal to c, and the sum of these two numbers is equal to b. Here is the list of factors of 30. The first is 1 and 30. The second is 2 and 15. Third, 3 and 10. Fourth, 5 and 6. Now on this column, we are going to add the factors. 1 plus 30 is 31. 2 plus 15 is 17. 3 plus 10 is 13. 5 plus 6 equals 11. As we can see here, this 13 here matches our B. It means to say the factors 3 and 10 is what we want for the M and N. So step 3, we are going to use the M and N as the last terms of the factors. So from here, the 3 and 10, we're going to put on the blanks. So it's now x plus 3 times x plus 10. Step 4 says, just to check our answer, we're going to multiply these two binomials. So x times x will give me x squared. X times 10 will be 10x. 3 times x is 3x. 3 times 10 is 30. In the middle terms, the 10x and the 3x, we can combine them. And the final answer is x squared plus 13x plus 30. And we can see that the product here is the same with our original trinomial on top. So what does it mean? It only means our answer here is correct. And this is our final answer. Let us have example 2. Factor x squared minus 11x plus 24. Step 1, let us write the factors as two binomials with first terms x. So x plus blank multiplied by x plus a blank. Step 2, let us now find the two numbers m and n. We are looking for the factors of 24, and here are the factors. 1 and 24, negative 1 and negative 24, 2 and 12, negative 2 and negative 12, 3 and 8, negative 3 and negative 8, 4 and 6, negative 4 and negative 6. And then on this column, we are going to add the factors. 1 plus 24 is 25. Negative 1 plus negative 24 is negative 25. 2 plus 12 is 14. Negative 2 plus negative 12 is negative 14. 3 plus 8 is 11. Negative 3 plus negative 8 is negative 11. 4 plus 6 is 10. Negative 4 plus negative 6 is negative 10. We can see now that this negative 11 as the sum matches our value of b. So it means to say we're going to use the m and n as the last terms of the factors. That is the step 3. This negative 3 and negative 8 are our m and n respectively. So we're going to put these two values on the blanks. So this is now our binomials. X minus 3 times x minus 8. In step 4, if our answer is correct, by multiplying these two binomials. So we have now x times x is x squared. X times negative 8 is negative 8x. Then negative 3 times x is negative 3x. Then negative 3 times negative 8 is positive 24. And then the middle terms, we can see that they are like terms that we can combine. So we have now the final answer, x squared minus 11x plus 24. And our answer here is the same with our original trinomial on top. It means the x minus 3 times x minus 8, and that is our final answer. Let us have example 3. Factor the trinomial x squared minus 2x minus 35. Step 1. Write the factors as two binomials with first terms x. So here it is, x plus blank times x plus blank. And then let us find two numbers, m and n. So we're going to find the factors of this negative 35. So the factors of negative 35 are on this column. First pair is 1 times negative 35. Second is negative 1 times 35. Third, 5 times negative 7. Fourth, negative 5 times 7. On this column, we're going to add the factors. 1 plus negative 35 is negative 34. Negative 1 plus 35 is 34. 5 plus negative 7 is negative 2. Negative 5 plus 7 equals 2. But we're looking for a sum that is equal to the b, and here it is, the negative 2. It means to say, we're going to the step 3 to use the m and n, these two terms here, this pair of factors, to be placed on the blanks. So here it is now, we have the x plus 5 times x minus 7. So step 4, we will check our answer if correct by multiplying these two factors. And we will hope that the answer will be same with our trinomial here. So multiplying the x and the x, that is x squared, x times negative 7 is negative 7x. Then 5 times x is positive 5x. 5 times negative 7 is negative 35. So we're going to combine the two terms in the middle, the negative 7x and the 5x. We will have a negative 2x. So our final answer here is x squared minus 2x minus 35. And we can see that the answer here is the same with our original trinomial on top. It means to say the binomials x plus 5 times x minus 7 are correct and considered to be our final answer. Let us have example 4. Let us factor x squared minus 6x plus 10. Step 1, I'm going to put here the x plus blank and then times x plus blank. Step 2, let us find two numbers m and n, the factors of 10, such that later on we will add them to get a value of b. So on this column, the factors of 10 are 1 and 10, negative 1 and negative 10, 2 and 5, negative 2 and negative 5. In this column, we're going to add each pair of factors. 1 plus 10 is 11. Negative 1 plus negative 10 is negative 11. 2 plus 5 is 7. Negative 2 plus negative 5 equals negative 7. As we can see here, there are no pair of factors of 10 to get a sum of negative 6. In this case, we will say that this trinomial is non-factorable, and this will be our answer here. Let us put some notes here. We know that we are factoring a trinomial that is equal to two binomials, and that is x plus m times x plus n. If c is positive, the c here is the constant of our trinomial. It means to say the m and n. The m and n are here, should have the same sign. It can be both positive or both negative. Look at our previous examples 1 and 2. In example 1, the constant is 30 and positive. So look at our factors here. The 3 and 10 are both positive. Also, the sign of the b will tell us that the signs of the m and n should be both positive. Let's have example 2. The constant is positive 24. So look at our m and n. They have the same signs and both negative. Considering the sign of the b here, since it is negative, it gives us idea that these two binomials in the m and n should have both negative also. Now, if c is negative, the m and n should have different signs. Look at our example 3. Our constant here is negative 35. The values of m and n have different signs. One is positive, the other is negative. And there is another clause here. The bigger number between m and n should have same sign with b. So the numbers 5 and 7 is bigger, and because the sign of the b is negative, the 7 as the bigger number will have the negative sign also. Hi everyone, today we're going to study factoring, and we're going to factor a trinomial of this form: ax squared plus bx plus c. How do we factor a trinomial of this form? We are going to follow some steps. Step 1 is factor any greatest common factor, or GCF. Step 2, find the product AC. This AC means the A, the coefficient of x squared, and the C, the constant of the trinomial. Step 3, we're going to find two numbers m and n, such that if we multiply the m and n, this is equal to the AC. This AC coming from step 2. Also, if we add the m and n, we can see it is m plus n. It must be equal to the b. and this b is the coefficient of the x in the middle term of the trinomial. Step 4. Split the middle term using m and n. It means to say the ax squared plus bx plus c will become like this: ax squared plus mx plus nx plus c. Step 5. We're going to factor by grouping. Let us have example 1. Let us factor out 10x squared minus 55x plus 70. Step 1 says, let us factor any greatest common factor. For this trinomial, we can see that there is a common factor of 5. So we can factor out that number 5. So what remains in the first term will be 2x squared. For the second term, now becomes negative 11x. And the third term, 70, will become 14. Step 2. Let us find the product AC. After removing the greatest common factor, we have now our new trinomial here to be 2x squared minus 11x plus 14. Now taking the AC, it means the a, which is the coefficient of x squared, it is 2, and the c is the constant 14. Now multiplying the a and c, 2 times 14 equals 28. In step 3, we're going to find two numbers that when we multiply these two numbers m and n, it must be equal to 28. But if we add the m and n, it must be equal to the b. And this b is the coefficient of the middle term of the trinomial. After considering many pairs of factors, it was found that the negative 4 and the negative 7, if we multiply, will be equal to 28. Also, if we add the negative 4 and the negative 7, it is equal to negative 11. So the 28 here is the product AC, and the negative 11 is the B. So step 4, we're going to split the middle term using m and n. It means to say, we're going to rewrite this trinomial, but the middle term, we must split it using this m and n here. So as you see now, in this line, the 5 is copied. The 2x squared is copied down here. The negative 11x is now split into negative 4x and negative 7x. And then plus the constant 14. And in step 5, we're going to factor by grouping. So we have here 4 terms. We're going to group the first 2 and also the last 2. So the 2x squared minus 4x is now in one group. The negative 7x plus 14 is in another group. And using that factor by grouping, we are going to factor out a common factor or greatest common factor for these 2 terms. Also, we will do the same on the next group. So in here we can see that 2x is the GCF. So we put the 2x outside. what remains inside for this term will be x, and for the negative 4x, what remains is the negative 2. If we want to check if our factoring are correct, we can multiply 2x times x. We will get back the 2x squared, and then 2x times negative 2, we will get the negative 4x back. Now, for the second group, we want this x to be positive, so we're going to factor out a negative 7. So when we factor out the negative 7, what remains here will be positive x. And for the positive 14, what remains is a negative 2. Again, just to check if these factors are correct, we can multiply and see if we can get the original binomial back. So the negative 7 times x is negative 7x, and negative 7 times the negative 2 is positive 14. So we are sure that these factors are correct. And now we have two big groups here, and we can see that there is a common factor for these two big groups, and that common is the binomial x minus 2. So we can factor that x minus 2 out. It will be like this. First, we copy the number 5. Now this common x minus 2 we'll put in here, and on the second factor we will collect the remaining terms after removing the common factor. So 2x is copied here, and then the negative 7. So for our answer, the factors are 5 and x minus 2 and 2x minus 7. So this is our final answer. Let us have example 2. Factor out 6x squared plus 7x plus 2. Step 1 says, let us factor any GCF. But there is no GCF here. So we will proceed with step 2. We're going to find the product AC. The coefficient of x squared is the A, and that is 6. The constant 2, that is the C, we will multiply here. 6 times 2 equals 12. And then step 3, we're going to find two numbers, and these two numbers are factors of 12. And at the same time, if we add the two numbers, it must be equal to B, and that B is that number 7. After considering many pairs of factors, we found that 3 times 4 equals 12, and that is the AC, and 3 plus 4 equals 7, and that is the B. So now we're going to split this middle term using the M and N. So the 3 and the 4 are our M and N respectively. So writing this again, 6x squared is here. Instead of writing 7x, we will now write 3x plus 4x, and then plus the constant 2. Step 5, we are now to factor by grouping. We're going to group the first two terms and then group the last two terms. We're going to factor out the GCF for these two terms. We can see that 3x is common. So what remains in the first term, 6x squared, is 2x, and then plus 1. We can check if our factors are correct. 3x times 2x is 6x squared. 3x times 1 is positive 3x. For the second group, The common factor is 2, so we remove the number 2 outside, and what remains with the 4x is 2x, and then for the 2, it becomes 1. Again, let us check ourselves if the factors are correct. 2 times 2x is 4x, 2 times 1 is positive 2. So we are sure that these factors are correct. Now, we have two big groups here, and there is a common in these two big groups. And the common is that binomial 2x plus 1. There is also 2x plus 1 here. So we're going to factor out the 2x plus 1. It is now in here. And for the second factor, it is simply the remaining terms for each of the big groups. So the 3x is copied here, and then plus the 2. So our factors, 2x plus 1 times the 3x plus 2. Hi everyone, today we're going to study factoring. This time we're going to factor by grouping. How to factor by grouping? We're going to follow these 4 general steps. In step 1, we're going to group terms with common factors. Step 2, we will factor out the common factor in each group. Step 3, factor the common factor from the expression. Step 4, check by multiplying the factors. Let us have example 1. Let's factor out these 4 terms, xy plus y plus 2x plus 2. In step 1, we're going to group terms with common factors. So I'm going to group the first 2 terms, xy plus y, and the last 2 terms, 2x plus 2. In step 2, factor out the common factor in each group. In the first group, the variable y is common, so I'm going to factor it out. So y comes out. What remains inside is the x plus 1. For checking, I'm going to multiply this y to this x, so I will get back the xy, and then y times 1 is y. So I'm sure that this is a correct factors for the first group. In the second group, the common is the number 2. So I'm going to bring out that number 2, and what remains inside is the x plus 1. So checking again, 2 times x is 2x, 2 times 1 is 2. So I'm sure that this is a correct factors for the second group. In step 3, factor the common factor from the expression. We have now here 2 big groups. For each group, the common factor is the binomial x plus 1. So I'm going to bring out that common factor outside. So it is now x plus 1. Since we have 2 big groups, the second factor should be a binomial also. So I'm going to collect all the terms that will remain after removing the common factor from each group. So in here, it is y, and then plus the 2. In step 4, let us multiply the factors to check if our answer or if the factors are correct. So x multiplied by y, I will get that xy. X times 2, I will have this 2x. And then 1 times y, we'll get back that y. And 1 times 2 is 2. So these factors are the correct answer. Let us have example 2. 2x cubed minus x squared minus 10x plus 5. Step 1. Group terms with common factors. So I'm going to group the first two terms and group the last two terms. But you see here, our third term is negative. So while putting the grouping symbol, I should write here the plus and then put the last two terms in the grouping symbol. In step 2, factor out the common factor in each group. The common is the x squared. So I'm going to pull out the x squared. So what remains will be 2x minus 1. In the second group, the common is 5. But I should write negative 5 so that later the binomial here will come to be on the same value with the 2x minus 1 of the first group. So if I pull out the negative 5, what remains here is the 2x minus 1. Before going further, I must check myself if the factors are correct. The negative 5 multiplied by 2x, I will get the negative 10x back. The negative 5 times negative 1 is positive 5. So these factors are correct for the second group. And then for step 3, we will factor the common from the expression. So from the two big groups, the common factor is that binomial 2x minus 1. So I'm going to pull it out. So 2x minus 1 is now here. And for the second factor, I put 2 blanks because since I have binomials in here, I should have a binomial also in the second factor down here. And then to collect the remaining terms after removing the common factor from the group 1 here, x squared I should copy down here. And for the second group, the negative 5. So for step 4, I'm going to check by multiplying the factors. So the 2x times x squared, the answer is the 2x cubed. 2x times negative 5, I will get the negative 10x. Then negative 1 times x squared, it is negative x squared. Negative 1 times negative 5 is positive 5. So we are now sure that our answer is correct. Let us have example 3. Factor out 2x minus 9y plus 18 minus xy. So let us group terms with common factors. If I group the 2x minus 9y, there is no common between these two terms. Also, the 18 minus xy, if I group these two, there is no common factors for these last two terms. So what I'm going to do is to rearrange the terms. I can put the 2x on the last part. So it's now negative 9y plus 18 minus xy plus 2x. And then from here, I can see now that there is a common factor in the first two terms. Also, there is common in the last two terms. So it's now the quantity negative 9y plus 18 plus. So again, I see here that the third term is negative xy. So I must be careful. I should put here the plus and put the grouping symbol for the negative xy plus 2x. And step 2, factor out the common factor. In the first group, the common factor is 9. But I want this variable y to be positive, so I should pull out negative 9. And if I do that, the remaining terms inside here should be y minus 2. Now, to check myself, the negative 9, if I multiply it by y, I will get back the negative 9y. The negative 9 times the negative 2 equals positive 18. So I'm sure that these factors are correct for the first group. Now, for the second group, I want that y to be positive also, so I should factor out a negative x. So what remains here now is positive y and then negative 2. So let us check again if the factors are correct. I'm going to multiply negative x by y. It will be negative xy. The negative x times negative 2 will be positive 2x. So I'm sure now that these factors are correct for the second group. And for step 3, let us factor the common factor from the expression. So the common is the y minus 2. It is now down here. And for the second factor here should be a binomial. I will simply collect the terms that will remain after removing the common factor. For the first group, the negative 9 will come here. For the second group, the negative x will remain, and I should copy that down here. And for the step 4, I should multiply the factors to check if it is correct. So y times negative 9, I will get the negative 9y. Then y times negative x, here is the negative xy. Negative 2 times negative 9, I will have this positive 18. Negative 2 times negative x will be positive 2x. So now I am sure that my factors here are correct. And this is our final answer. Let us have example 4. Factor out x squared minus 6x plus 9 minus y squared. Step 1. Group terms with common factors. If I group the first two terms, I can see that there is common between them, and that is x. However, if I'm going to group the last two terms, there is no common for these two. So this is a special case. It is possible that I can group the first three terms. So x squared minus 6x plus y is now taken as one group, and then the negative y squared will be alone. And then this trinomial, I can factor it out into the square of difference of two terms. Then I will just copy the negative y squared here. In step 2, I'm going to factor out using the special product difference of two squares, and this is the formula. When we have a squared minus b squared, the answer will be the binomial a plus b times the a minus b. In this case, the x minus 3 is considered to be the a and the y is the b. So in applying this formula, it will be like this. So the a, the x minus 3, I will copy here. Then first I'm going to put the plus sign and then the y. And then multiplied by the quantity x minus 3. This is the a again. And then this time should be minus and the y. And then I'm going to simply remove the grouping symbol inside the square brackets. So the parenthesis inside is now removed. So these are the factors. So step 3, we're going to check by multiplying the factors if these are correct. So if I'm going to take one term each from this group and to multiply to the other group, this will be the product. So x times x will be x squared. X times negative 3 is negative 3x. X times negative y is negative xy. Next is negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Negative 3 times negative y is positive 3y. Now for the y, times x is positive xy. Then y times negative 3 equals negative 3y. And y times negative y equals negative y squared. And from here, let us see some terms that we can combine or cancel. This negative xy, there is a positive xy down here that we can cancel both of them. Also look at the positive 3y. There is a negative 3y in here. So both terms are cancelled. And then we will collect what will remain, the x squared. Then we have this negative 3x and negative 3x. Combining them, we'll get the negative 6x. We will copy the 9 and the negative y squared down here. So you see, the final answer here equals our original problem. So it means this trinomial and another trinomial here is our final answer. Hi everyone. Today we're going to do factoring. We will factor sum and difference of two cubes. And this is the form x cubed plus or minus y cubed. First, let us review our special product when we multiply binomial times trinomial of this form. So x plus y times x squared minus xy plus y squared. The product is x cubed plus y cubed. Our product here is related to our binomial factor. It's like we take the first term of the binomial factor, put it here, and then put a power 3. And then the positive sign is copied here. The second term y is written here and then power 3. So let us analyze the trinomial factor. The first term of this trinomial factor is the square of x, and the x is actually the first term of our binomial factor. The y squared is the square of y, and that y is the second term of our binomial factor. The middle term is the product of these two terms, in the binomial factor x times y. But on the pattern, we should write the opposite sign. So our special product here now is the sum of two cubes. Also, when we have the x minus y times x squared plus xy plus y squared, the answer is x cubed minus y cubed. And this is the difference of two perfect cubes. The pattern is the same. The binomial factor is related to our product. The first term x is placed on the product and with power 3, and then minus. Take note that our sign here is the same with our sign in our product, followed by the y is placed here and then with power 3. For the trinomial factor, the first term x squared comes when we square the first term x in here. The last term y squared comes from when we square the negative y. It will give us positive y squared. The middle term xy comes when we multiply the x times the negative y. We get a negative xy, but based on the pattern, we should write the opposite sign. So you see here in the middle, it is positive xy. For today's lesson, we will do the reverse process. The problem will come the sum of two cubes or the difference of two cubes. And you will be required to provide the factors of this form or of this form. How to factor sum or difference of two cubes. We are going to have these three steps. Step 1, write the terms as cubes. Step 2, use the sum or difference of cubes pattern. And the patterns are here. And step 3, simplify. Let us apply these steps to solve some problems. Let us have example 1. Factor x cubed plus 64. The steps are here. So we will apply the step 1 first. Write the terms as cubes. So x cubed here is now written as the cube of x, and then plus the 64 is equal to the cube of 4. And then step 2, we're going to write the factors. In the factors, we expect a binomial times a trinomial. Let us write the binomial first. We will write the x, we will copy the positive sign, and we will copy the number 4. So our binomial is the x plus 4. For the trinomial, the first blank is the square of this x. So I write here the square of x. The last term is the square of the number 4, or the second term of the binomial. In the middle term, I am going to multiply the two terms here. So x times 4. But take note that we will use the opposite sign. So all the terms are now in place. We will just simply go to step 3 to simplify. I will copy the binomial, and then for the trinomial, I will simplify the square of x to be x squared. The middle term becomes negative 4x, and the 4 square is now written as 16. So this is our final answer. Let's have example 2. Factor 8x cubed minus 27y cubed. Let us first write the terms as cubes. The 8x cubed is now the cube of 2x, and then minus. The 27y cubed is now the cube of 3y. Step 2, we will write the factors. Again, in the factors, we expect binomial times trinomial. Let us begin with a binomial. I will now copy the 2x, and then the negative sign is copied here, followed by the second term, and that is the 3y. So our binomial is 2x minus 3y. For the trinomial, the first blank is reserved for the square of 2x. The last term is reserved for the square of this negative 3y. Look at the middle term. I'm going to multiply the 2x and the negative 3y here, but later we should write the opposite sign. If I multiply a positive by a negative number, of course the sign will be negative. But based on the pattern, I should write the opposite sign. So going to step 3, I will now simplify. First, I copy down here the binomial factor. For the first term, the square of 2x is now 4x squared. For the middle term, I multiply the 2x times the negative 3y. It will be negative 6xy, but I should write the opposite sign. So this is plus. The square of negative 3y is now positive 9y squared. So this is our final answer. Let's have example 3. Factor negative 2x cubed y squared minus 16y raised to 5. We can observe that the terms are not perfect cubes. But remember, let us check for greatest common factor. I observe that the GCF is the negative 2y squared. So when I factor out the GCF, the first term becomes x cubed. The second term becomes positive 8y cubed. And from here, we can now apply our steps in factoring sum of two cubes. Let us write the terms as cubes. So first I copied the GCF, negative 2y squared, and then the x cube is now written here as the cube of x. For the 8y cube is now the cube of 2y. Now let us go to step 2. Let us write the factors. We expect binomial times trinomial. So in our binomial, let us now write the x followed by the positive sign followed by the 2y. So our binomial is x plus 2y. For the trinomial, the first term is the square of x. The last term is the square of this 2y. The middle term is the product of the two terms of the binomial factor, but we should write the opposite sign. So all the terms are now in place. We will now simplify. I copied first the GCF followed by the binomial factor. Let us simplify now. Our trinomial factor the first term is now x squared. The middle term is now negative 2xy. And then plus the square of 2y is now 4y squared. So this is our final answer. I hope you learned something from this video. See you again next time.